Hi, I am Ege. Today I'm talking about our machine learning project. Football is the most beautiful game in the world. This beauty comes from its unpredictability. This unpredictability comes from its variables. Compared than the other games, football has 22 different players on this field. UEFA Champions League is the most biggest football competition in the world. Our goal is to predict the last 16 teams on the UEFA Champions League. We have 3 different motivations to choose that project. First one is we have interest on football with my project mate. His name is Fatih. Second motivation of this project is football is the one of the biggest industries of a country, and it's increasing. Third one of our motivation is football is an unpredictable game. When you compare the other ones, for example, basketball, in a basketball field, there are 10 players on the field, but in football, there are 22 different players on the field. This unpredictability actually makes football beautiful because, for example, when you watch a game and one team played good game, but they cannot win sometimes, and this gives a football unpredictability, and that's why we chose that project, because you know that AI is the good on the unpredictable environments.
Social impact. Social impact of soccer is so huge to compare the other ones, because soccer affects the most of the countries, especially European countries. There is an example of a stadium from Europe. We can look at existing works. Most effective works on particular area is about XG. Its expected goal is a predictive model used to assess every goal scoring chance. AI is used widely in this particular area. You can see the example of the XG. There were just, by the way, in existing works, there were just statistical analysis too, but these don't use a AI model. They just look on the comparison of the two teams, like which one make more goals or rating. This chart compares the two clubs on different topics.
Hi guys, I am Fatih Çeykel. Again, talked about what is title, what is objective of work, what is motivation of work, what is scope of work, what is social impact for this project, etc. I am talking about dataset description, what is methodologies used, algorithm used, why can we select this data, select this algorithm, implementation and analysis, conclusion, etc. We consider a lot of options. We think we can get this from websites. It's simple. As you can see, we can get rated data, and we decided to use rated data because there are a lot of simple good data in Kaggle. If we get this from somewhere, we have to work a lot of data cleaning work. Therefore, we choose this. This data is very simple for this prediction. Simple and useful because goals, shoots, position, rating, etc. They are basis fundamental of football, but still we have a little bit work for preparing the algorithms, because during the ancient times, yellow cards and red cards is important for football, but nowadays I am not sure, because modern football is based on position, a lot of position. Number of cards shows maybe full rates, shows hard played football and unsportsmanlike act, but it's not related to defense and position. Repeatedly, ancient time, it's okay, but we are playing the modern football now. We can use this article, I think. Yeah, this article. We can use for this prediction key nearest neighbors or logistic regression analysis, simple regression analysis, nav-wise classifier, support vector machine, random forest for this prediction, but we choose multiple linear regression. I will tell you why we choose it, why I will talk about multiple linear regression. I have to talk about simple linear regression before the algorithms, what we use it. Linear regression is linear approach is simple. Is relationship between two variables. Maybe we can say x and y variables. As you can see, y and x variable and connect them with relationship. It's relationship. This is relationship. Also, this variable will maybe dependent or independent variable. After the define this relationship line, relationship for formulation. If we look at this graph, we cannot see x6 connect the unknown y, but we can say if x will be 6, will be 11. It's a prediction. This is good for us. It's very simple other regression type. Therefore, we choose it. Maybe best option is SVM, but SVM, but SVM a little bit tough for us, and SVM is not effective when we working on huge data. It's difficult to understand because increase the dimension and solve it a little bit tough, we think. Therefore, we choose it multiple linear regression. Multiple linear regression. Time to tell about multiple linear regression. It's also very easy, very simple. If we have more than two variable, we can use it. We can choose it. Can choose it. As you can see, a lot of x variables, more than two variables, a lot of x variables connect the y variable for use this formulation. Additionally, B0 shows intercept points. B1, B2, B3, etc. shows slope of this line. EG shows margin of error. We think if we will use multilinear regression properly, we can define the rating rate. It's true or not. We can say A team is playing good football, other than A team will attend the Champions League in the next year. B team is good play and will attend the Championship League in next year. Time to implementation part. Before we are starting, download the data. Okay, and upload it here. Okay, good. Important libraries. Okay, good. Important data sets. But a little changing now. His name. Okay, good. We need to delete something. Tournament, we didn't need this. Yellow cards and red cards, we didn't need this because it's modern football. And I prepare our thing. Yeah. Copy and paste. Like this. Print data set. Okay, it's good. I think it's fine, but a little bit change, I think. 1, 2, 7. I think it's good. It's good. Print the column names. Okay. And skip this. Because we don't have dumpy variable. Print the data. Train and work. Why? It's cycle cross validation, not. I think it's maybe cycle modern selection. Yep. Okay, good. Feature scaling. Okay. Cycle fitting to multiple linear regression in the training set. Okay, good. And prediction the test results, test and train results. I prepare before the implementation. Copy and paste. Okay, good.
Now we are gonna look at our analysis part, and we have to look on the importances of features, our features. These are like coefficient of multiple linear regression. These are like coefficients. Secondly, we looked on our accuracy of data, and that's why we have to import scikit-learn metrics. We looked on our accuracies, and that's not bad. We used the Seaborn library to visualize our data, and that shows the most current 10 teams also. We can look on most current 10 teams. First one is Bayern Munich, second one is Paris Saint-Germain, third one is Barcelona. Now we are going to look at the most positioner 10 teams, and we use the Seaborn library again. First one is Barcelona, second one is Manchester City, third one is Paris Saint-Germain. And we can look on our features histogram, and this histogram can give information about our features, and that's the analysis part.
Print the rating scores and print the linear regression results for rating, and we define the we'll define the team that will attend the Champions League in next year.
As a conclusion, we made the data pre-processing, multiple linear regression, and analyzed the data, and
we predict the last 16 teams of UEFA Champions League.
let's talk on last 16 teams on UCL.
Let's connect to our announcer that is on the field to announce the last 16 teams.
Hi Fatih, Manchester City, Bayern Munich, Paris Saint-Germain, Barcelona, Real Madrid, Manchester United, Juventus, Aston Villa, Borussia Dortmund, Atlanta Madrid, Atlanta, Chelsea, Liverpool, Milan, Lille, Tottenham. Have a nice day.
Thanks to Emir, and have a nice day.
Have a nice day, Emir. These are our references.